The most common pattern is the one-to-many pattern, meaning that there's one row in the primary table with a primary key, and it relates to multiple rows in the secondary table using a foreign key. For an example, let's look at an order detail table. So let me switch back to Management Studio, and in the OBX Kites, there is a database diagram I just made up called one-to-many. Opening this up, here is the order detail table. You can see the diagram shows a primary key here, meaning 1. It's hard to see, but it's a little infinity symbol here, meaning many. If we select the relationship line, over in the properties, we can actually open this up and see the foreign key is order detail, order ID. Here's order detail and the order ID column. Back on the relationship line, open this up once again. And then the primary or unique is order and order ID. So this is the one-to-many relationship. We'll see this over and over again once we start getting into building SQL statements that pull from multiple tables when we do joins. Typically, you'll do joins and pull data from these one-to-many relationships so you can pull out meaningful data. The second most common relationship is a many-to-many relationship. Sometimes in a many-to-many relationship, that connection between the two is an obvious table that most users or most business people would understand. For example, between order and product, most people understand there has to be some kind of detail row there that connects an order with a product. However, sometimes that table as a supporting table is going to be difficult to be understood by the average business user. So between members and groups, they would think of it as a direct connection of a many-to-many between many members can be in many groups, each group can have many members, but we need to build a supporting table to physically represent that logical many-to-many connection. Let me show you over in Management Studio what I'm talking about. In the KPatterns Adventures database, there is that example of many-to-many. This is an event, and here's customers. Each customer can attend multiple events. Each event can have multiple customers attending it. So this is a table that has the many-to-many. Notice how this is built. From this side, from the customer side, there's one customer and many representations here. On the event side, there's one event, many representations of the customer. So this many-to-many, sometimes called a junction table, more properly called an associative table, creates that physical link, producing a many-to-many logical link between customers and events. So that's the many-to-many pattern, and you'll see it often inside of a database. The third pattern I want to show you is the supertype-subtype pattern. The supertype-subtype pattern is useful when you have a situation where it's difficult to decide, do you want to put everything together in one entity or separate it out into multiple different entities. For example, in this diagram, there are certain attributes or certain columns that are going to be common to employees, customers, vendors, and shippers, such as address, name, maybe phone number. However, employees will have an employee ID, start date, terminate date, reports to, position, something like that. Customers might have information that is specific to customers, such as last purchase date, maybe volume to date, year to date, something like that. Vendors would have a vendor ID, preferred shipping. Shippers would have information specific only to shippers. So we have a situation where, on one sense, they're all contacts and they share the same information, but on the other sense that they are individualized into separate subgroups. So the supertype-subtype pattern is used to solve that dilemma, allowing you to put all of the contacts together in the one contact table with their common attributes and then break out the specific attributes into a separate table for specific employees, customers, vendors, and shippers. To select the data then to see all the information about an employee, you would have to join between contacts and employees. To see your customer information, you have to join between contacts and customers. So it does require a join to get out all the information. However, if you want to put together a list of who's everybody we have anything to do with for the purposes of mailing, say, Christmas cards or something like that, it can be done directly from the contacts table. This kind of pattern also helps mimic in a relational database an object-oriented front end, because you can, in one sense, build inheritance or the is-a relationships. For example, an employee is a contact, a vendor is a contact, and a shipper is a contact. But not every contact is an employee, vendor, or shipper, just how inheritance works for OO. There's an example of this in AdventureWorks. Let me show you. Let me open up a diagram. So here's the contact, which is the supertype. The employee is the subtype of the contact. Looking at the relationship and opening it up in properties, there's the contact ID in employee relating to the contact ID in person. And then salesperson is a subtype even of the employees. So there's a supertype, subtype relationship, so you can see how it looks in the physical database diagramming tool. The fourth common pattern I want to show you is the reflexive pattern. It's used commonly for hierarchies. Sometimes it's called a unary or a self-join type pattern. Another proper term for this would be called an adjacency pairs pattern. It's also called a recursive type pattern because in the hierarchy, it could be a person relating to a person relating to a person, and it's sometimes called an elephant ear pattern informally because of the way it looks when it's drawn. Because the reflexive pattern is used for hierarchies, let me just describe a couple of cases where this might be used in practice. An organizational chart has an employee reporting to another employee, reporting to another employee. This is the example used in Northwind. It's the most common example of a hierarchy or this type of pattern being used. It can also be used in a species list or a jurisdictions, because a jurisdiction is within another jurisdiction, city, county, state, some other larger region or country than international. The reflexive pattern is also useful for genealogies, and that's the example I want to show you. So to show the reflexive pattern or the adjacency pairs pattern in the family database, this time I'm going to go ahead and create the database diagram and let you see this live. First we do is we enable database diagramming, new database diagram, include just the person table, slide this down, and there's two elephant ears. Basically, if we look at these, select one table, it's saying that there's a foreign key on mother and a primary key on person. So to look at this in another way, here's the person's mother, which relates back up to the person ID of the mother. Here's another one. To look at this one, it's saying here's the person ID. For the primary key would be person ID. That would be the row of the father. And then here's the row of the child. And there's a column called Father ID, which contains the actual identifier of the father. Let me open this up so you can see the data. Maybe we'll make that a little bit easier to understand. And bring this in some. So here's Father ID and Mother ID. This is Father ID 26. So Adam's father is ID 26. Just scan quickly and find that, and that would be Richard Campbell. So what we're saying is that Adam's father is Richard. There's the 26 to 26. His mother is ID 8, which would be Melanie. So this is how we do that adjacency pairs. It's called adjacency pairs because in one row, we're storing both the person ID and then adjacent, well, not physically right here, but adjacent logically, is the representation of the next row up. So that's the adjacency pairs of handling hierarchies in the database.